Chapter 6 Benzene. Subtopics which you will study under benzene and its derivatives are 6.1 Introduction, 6.2 Nomenclature of benzene and its derivatives, 6.3 Chemical properties of benzene and its derivatives. Introduction to benzene and its derivatives will describe about aromaticity, Kekulé structure, and resonance structure of benzene. Aromatic compound or arene is an organic compound that contains at least one benzene ring or other ring structure that resembles benzene in its chemical properties. Initially, they are called aromatic because of its odor, but now aromaticity refers to the stability of compounds that are considered aromatic. So, what is the criteria for aromaticity? Criteria for aromaticity is the molecule must be first, cyclic, a ring of atoms; second, planar, where all the atoms in the molecule lie in the same plane; third, completely conjugated, which means delocalized electrons in compounds with alternating single and multiple bonds; fourth, number of pi electrons must satisfy Huckel's rule, which is 4n plus 2, where n equals 0, 1, 2, and so on. Example to determine whether benzene and cyclobutadiene are aromatic compound or not. Benzene fulfill all the criteria for aromaticity, which the molecule is cyclic, planar, completely conjugated, and satisfy Huckel's rule, which has 6 pi electron, able to get the integer for n, where 4n plus 2 is equal to 6 and n equals 1. Benzene is an aromatic compound. Cyclobutadiene only fulfill 3 criteria for aromaticity, which the molecule is cyclic, planar, and completely conjugated, but not satisfy Huckel's rule, which has 4 pi electron, unable to get the integer for n, so cyclobutadiene is not an aromatic compound. Kekulé structure. August Kekulé, a German organic chemist, proposed the first benzene structure in 1865, suggesting that the benzene structure contained a 6-membered ring of carbon atoms with alternating single and double bonds. Molecular formula of benzene is C6H6. In Kekulé description, the bonds between 2 carbon atoms is sometimes a single bond and sometimes a double bond, so Kekulé suggested that a fast equilibrium interconverts the 2 isomers of benzene. Resonance structure. Benzene has 2 resonance structure, so benzene is actually a resonance hybrid of the 2 Kekulé structures. The electrons in the pi bonds are delocalized around the ring. Because each pi bond has 2 electrons, benzene has 6 pi electrons. The circle represents the 6 pi electrons, which are delocalized, distributed over the 6 atoms of the ring. 6.2 Nomenclature of benzene and its derivatives. Under this subtopic, you need to draw and name benzene derivatives according to the UPAC nomenclature for: first, monosubstituted benzenes; second, disubstituted benzenes which divided into same substituents with prefixes ortho, meta, para, and different substituents; third, tri- and tetrasubstituted benzenes. Draw and name the benzene as substituents, phenyl or benzyl. Structure of benzene. Benzene normally draw as below. The benzene structure also can draw as resonance hybrid structure. For nomenclature monosubstituted benzene, which has only one substituent, name the substituent and add the word benzene. Example, for this structure, fluorine as substituent, and the name for fluorine as substituent is fluoro, and add the word benzene, so this structure name as fluorobenzene. For the second structure, NO2 as substituent, and the name for this substituent is nitro, and add the word benzene, so this structure name as nitrobenzene. For the third structure, CH2CH3 as substituent, and the name for this substituent is ethyl, and add the word benzene, so this structure name as ethylbenzene. UPAC rules allow some common names to be retained. Example, methylbenzene as toluene, hydroxybenzene as phenol, and aminobenzene as aniline. Disubstituted benzene, which has 2 same substituents. Relative position of substituents are indicated by prefixes ortho, meta, and para, or by the use of number. Ortho, abbreviated as O, is equivalent to 1 and 2 positions on a benzene. Meta, abbreviated as M, is equivalent to 1 and 3 positions on a benzene. And para, abbreviated as P, is equivalent to 1 and 4 positions on a benzene. Example: 1,2-dibromobenzene, also known as orthodibromo-benzene. 1,3-dibromobenzene, known as meta-dibromobenzene, and 1,4-dibromobenzene, known as para-dibromobenzene. Substituted benzene with two different substituents. Naming is based on the alphabetized the names of substituents preceding the word benzene. Example for this structure: chlorine is chloro, and bromine is bromo. Follow alphabet. B is in front C, so bromo first followed by chloro. So bromo will get the lowest numbering, which is 1, and chloro will get the higher numbering, which is 2. So this structure called 1-bromo-2-chlorobenzene or ortho-bromochlorobenzene. Example: this structure: NO2 is nitro, Cl is chloro. Just because follow the alphabetical system, C is in front N. So when naming chloro first followed by nitro, chloro will get the lowest numbering, which is 1, and nitro will get the higher numbering, which is 3. This structure is named as 1-chloro-3-nitrobenzene or metachloronitrobenzene. If one of the substituents is part of a common root, name this monosubstituted benzene as parent name and numbered as carbon 1. Example for this molecule structure: one of the substituents is part of a common root. So this monosubstituted benzene is parent and name is benzoic acid, and the carbon which attached to this substituent will have the lowest numbering, which is 1. Another substituent is NO2, which name is nitro, and when writing the number for the benzene ring clockwise 1 to 6 and anti-clockwise 1 to 6, the position of carbon for nitro must has the lower number, so between number 2 and 6, 2 is selected as position of carbon for nitro. The name for this structure is 2-nitrobenzoic acid or orthonitrobenzoic acid. Example for this molecule structure: one of the substituents is part of a common root. So this monosubstituted benzene is parent and name is toluene, and the carbon which attached to this substituent will have the lowest numbering, which is 1. Another substituent is Cl, which name is chloro, and when writing the number for the benzene ring clockwise 1 to 6 and anti-clockwise 1 to 6, the position of carbon for chloro must has the lower number, so between number 3 and 5, 3 is selected as position of carbon for chloro. The name for this structure is 3-chlorotoluene or metachlorotoluene. The increasing priority monosubstituted benzene as parent name, as list below, which carboxylic acids has the highest priority as parent name, and alkanes or halides has the lowest priority as parent name. For polysubstituted benzenes, examples: tri- and tetrasubstituted benzene, which means 3 or more substituents on benzene ring. 2 important steps you need to keep in mind are: first, determine whether the molecule with one substituent has a root name, parent name, or not. If no parent name, the molecule will ending with benzene. If has the parent name, the carbon attached to the substituents will become carbon number 1. Second, assign the lowest set of numbers around the ring and list alphabetize the substituent names. Example: refer to this structure. The structure did not has a root name or parent name, so ending name of the molecule is benzene. We will proceed for the second step, which will refer to the lowest set numbering and follow alphabetical order. When numbering around the benzene ring clockwise 1 to 6 and anti-clockwise 1 to 6, we will getting 2 set of numbering at the 3 substituents, which are first 1, 2 and 4 follow clockwise numbering, and second 1, 2 and 5 follow anti-clockwise numbering. So the lowest set of numbers is 1, 2 and 4 is selected as the position for the 3 substituents. This molecule has the same 3 substituent Br, which name is bromo. For the repeating substituent's name, Greek numerical prefixes are used to dictate the number. Example: if 2 will use D, 3 will use tri, and 4 will use tetra, and so on. For this structure, because same 3 substituent Br, so we will use tri to indicate 3. The name of this structure is 1,2,4-tribromobenzene. Another example. Please refer the structure given. The structure did not has a root name or parent name, so ending name of the molecule is benzene. We will proceed for the second step, which will refer to the lowest set numbering and follow alphabetical order. When numbering around the benzene ring clockwise 1 to 6 and anti-clockwise 1 to 6, we will getting two set of numbering at the four substituents, which are first 1, 2, 4, and 6 follow clockwise numbering, and second 1, 2, 3, and 5 follow anti-clockwise numbering. So the lowest numbering is 1, 2, 3, and 5 will assign on the carbon number. This molecule has four substituent, which is 2 Br as name bromo, 1 I as iodo, and 1 Cl as chloro. Follow the alphabetical order. Bromo will writing first, follow with chloro and iodo. Because this structure has two same substituents Br, so Greek numerical prefixes D will use on bromo. The correct nomenclature for this structure is 1,2-bromo-3-chloro-5-iodobenzene. For this example, the structure has a root name or parent name, which name is aniline, so this will be the ending name for the structure, and the carbon attached to the substituents will assign as carbon number 1. We will proceed for the second step, which will refer to the lowest set numbering and follow alphabetical order. So, when numbering around the benzene ring clockwise 1 to 6 and anti-clockwise 1 to 6, we will getting two set of numbering at the four substituents, which are first 1, 2, and 5 follow clockwise numbering, and second 1, 3, and 6 follow anti-clockwise numbering. So the lowest numbering is 1, 2, and 5 will assign on the carbon number. Br as substituent name as bromo, and Cl as substituent name as chloro. Follow the alphabetical order. Bromo will writing first, follow with chloro. The correct nomenclature for this structure is 2-bromo-5-chloroaniline. Benzene ring as substituent. Two structure of benzene as substituents, which are phenyl group and benzyl group. Phenyl group has the formula C6H5 with abbreviation pH, and benzyl group formula is C6H5CH2. Example phenyl group, 3-phenylpropene. Example benzyl group, chloromethyl, benzene or benzyl chloride. If alkyl substituent is larger than the ring, more than 6 carbon, the compound is named as phenyl, substituted alkane. Example for the structure below, alkyl substituent contains 7 carbon, which more than the carbon in benzene. The substituent now as parent chain, and name as heptane, and benzene as substituents, and name as phenyl. Position on phenyl is located in carbon number 2, which is the lower number, so the nomenclature for this molecule structure is 2-phenylheptane. If the chain is unsaturated, which have carbon-carbon double bond or carbon-carbon triple bond, or contains important functional group, the benzene ring is considered as phenyl substituent. Example, 1, phenyl, 2, butene, and 2, phenylethanol. 6.3 Chemical properties of benzene, and its derivatives. Type of chemical reactions of benzene is electrophilic aromatic substitution. Chemical reactions of benzene are halogenation, nitration, Friedel-Crafts alkylation, and Friedel-Crafts acylation. Reactions of alkyl benzene involved oxidation, hot acidified potassium permanganate, or potassium dichromate, and halogenation, which involved free radical substitution. Electrophilic aromatic substitution, the most characteristic reaction of benzene, which one of the ring hydrogen is substituted by atom or group of atoms. Benzene is electron-rich species, so it reacts with electrophile. Hydrogen atom is replaced by electrophile. Reaction of benzene, which is electrophilic aromatic substitution, involved group 17 elements halogen in presence of Lewis acid catalyst, such as ferric halides, is called halogenation, and the products formed are halobenzene and hydrogen halide. Nitration is the reaction of benzene with nitric acid and concentrated sulfuric acid at temperature 50 to 55 degrees Celsius. The chemical reaction will produce nitrobenzene and water. Friedel-Crafts alkylation is the reaction of benzene with alkyl halide and aluminum chloride. The products formed are alkyl benzene and hydrogen chloride. Friedel-Crafts acylation is the chemical reaction of benzene with acyl halide in the presence of aluminum chloride. The products formed are ketone and hydrogen chloride. Example for halogenation. Benzene reacts with bromine with presence of ferric bromide, will produce bromobenzene and hydrogen bromide. Nitration is the reaction of benzene with concentrated nitric acid and concentrated sulfuric acid at temperature 50 to 55 degrees Celsius. The chemical reaction will produce nitrobenzene and water. Friedel-Crafts alkylation. Benzene reacts with chloromethane, with presence of aluminum chloride, will produce toluene and hydrogen chloride. Friedel-Crafts acylation. Benzene reacts with acetyl chloride in the presence of aluminum chloride to produce acetophenone and hydrogen chloride. Reaction of alkylbenzene. First, oxidation. Reactants are benzene with benzylic hydrogen under conditions with hot and strong oxidizing agents, such as acidified potassium permanganate or potassium dichromate. Product formed as the alkyl side chain with benzylic H in the alkylbenzene is oxidized to COOH. What is benzylic hydrogen? Benzylic hydrogen is the hydrogen attached to the carbon that attached to the benzene ring. Example: the two structure below contain benzylic hydrogen. But for tert-butylbenzene, this structure didn't contain any benzylic hydrogen. Example: toluene. When reacted with hot acidified potassium dichromate, the alkyl side chain with benzylic H in the toluene is oxidized to COOH. Benzoic acid is formed. Example: tert-butylbenzene. When reacted with hot acidified sodium dichromate, no reaction, because the tert-butylbenzene didn't contain any benzylic hydrogen. Halogenation of toluene. Type of chemical reactions involved is free radical substitution, which take place at high temperature or in the presence of UV light. Example: reaction of toluene with chlorine in the presence of heat or lights results in formation of benzyl chloride and hydrogen chloride. Side chain chlorination, like halogenation of alkanes, may yield polyhalogenated products. Example: reaction of toluene with chlorine under heat or light produced benzyl chloride, and benzyl chloride with chlorine under heat or light produced dichloromethyl benzene and dichloromethyl benzene with chlorine under heat or light produced trichloromethyl benzene. End of chapter 6. Thank you.